Let's get started with the immutable object. So we have been doing a lot of things. Let me review for you. Basically, the first part, we have the computer programming variable, input, output. These are defining variables. And so the first part, we talk about variables. And the variable we talk about actually is we have integer data type, A, and then we reserve certain memory space over there, and we can put 3 in there if we assign A equals 3, right? And we have double B equals 3.5, same thing. We have memory location, we put 3.5 there. Okay, and then we have character, we have Boolean, right? Character used for X, it may be a character A or something. And Boolean, we have F, that may be true or false, right? Those are the variables we talked about so far. Let me see, somebody calling. Okay, your mom is calling, but I told her that we have class. Hello? Hello? 我们在上课，您在外面啊？我现在要开车回家。好，没问题，没问题，我已经跟他开始上课了，谢谢， 拜拜。好，拜。Okay, your mom called, and actually she probably don't know you have started. It's okay. Now let's continue. So these are called, these variable type are called primitive data type. Okay, so the word primitive means what? Primitive tribe, right? So primitive means not processed, right? Okay, you can say it's uncivilized, but I don't want to use the word. So not processed, right? Mm-hmm. Never been processed. So it's the original data. So you have the data that's original and never been processed. We call it primitive. So today we start to talk about something called reference type data. Okay, and in fact, reference type data, we already see it. String is a reference type data. Array is a reference type data. Reference type data is different from the primitive data. So primitive data, pretty much you have the integer A, you will allocate a memory space for it, okay? And that actually this memory will be put into certain space. But reference data type usually has a reference. It has a reference, but you will point to somewhere else. And they might be a big chunk of memory, say an array or a string. That is not a fixed size. That could be a 10 array, maybe 5 element array, maybe a long 100 character string or 20 character string. So the size of reference data type is not fixed. Size, we don't know. We don't know how long it depends on which way it has. Okay, so this is reference data type. But before we go into that reference data type, I'm going to talk about something called Java memory model. Okay, and pretty much this one probably, if you go to your school, I guarantee you nobody is going to teach you this. Even all the high school teacher doesn't know this actually. So now I'm going to teach you this Java memory model. Okay, this is, let me see, this Java memory model. No, not this one. This is not good. Let me find a better Java memory model to see. Okay, this one's better. Okay, this one's much better. So let me open it in. Let me actually open it in a new tab. Okay, this one's called Java memory model, right? Memory management. So this is a whole good article. Let me actually copy to you. Okay. So later you can read. You can read this one. This one is actually a good article. Wait, let me see. This one. So later you can still read. Okay. And this one, allow me to put it here. Let me put to chapter 9. It's an important link. Okay, so right here, let me see. Let me add a new article. And here I say memory model. Okay, every language has a memory model. Okay, and Java has its own. And then now we need to know about what is memory model. So here we have a few things: method area, okay, native method stack, Java stack, PC counter, and heap area. So for variables, what's more important is this one called Java heap. This one is very important: Java heap, Java stack, and this method area. Okay, these are the three important things we need to look at. Okay, these, let me circle it. Okay, these are the three important things we need to look at. And the Java variable could be in here, can be in here, can be in here, can be A, B, or C. A variable is declared in a Java program can be everywhere, can be A, B, or C. So now the reading here may be a little bit difficult for you, but that's not what I'm going to do. So what I'm going to do first is, let me actually bring up this one. Okay, let me actually try this memory model. Okay, now let's look at what is memory model. So let me clean up this. Okay, so the first thing is that I have a new program. So this is called memory model. Let me see. That's, don't call it memory model. This is no good. Let me call it. Let's call it circle. That would be better. Okay, let's call it circle. I want the circle one. It's probably better. Okay, so right here I can have like double radius. I put it here equals 1.0, right? And then I can have basically that's a 1.0. That's a circle, and it has data 1.0. But usually in the past we have a public static void main, something like that, right? And here has a variable a name called static, and we put string that is args. Okay, and then here we say that double area equals I call it master pi, right? And then times radius times radius, right? I try to calculate pi r squared, right? But okay, but right here, it has an error. What's the error? Non-static variable cannot be referred by static content. Okay, there's an error, and if you forget to put a static here, it will create trouble. But now, what really static mean? When we see a word static, what this static really means? That's the question I have, but I know you don't know. Don't worry, I'm not asking you. I actually will explain it. Okay? Don't worry. So what's the word static really mean? Okay, static means, when we say static means something that will be put into the global area. So the global area is actually means, I'm sorry, not this one. Where is my memory model? Right here. Okay, so when you put something called static, the static will go to the variable. When you say static, or a function you call static, static will put to this method area when you say static. Okay, when you say static, you put here. So apparently this radius is not put there, so it say that, oh, you cannot access that. Okay, so if a variable put here, this one is called instance variable. Okay, this one is called instance variable. And you data put here, this one is called local variable. Okay, I know you have a lot of questions. What is local? What is global? What is whatever? There are a lot of things that actually I don't know, right? But let me clear here. Okay, so this actually is not good. Okay, this is actually not good. It doesn't pass. So this one actually is useless. Okay, but here if I say static integer, say number of circle equals 0, right? And right here, let me say system dot out dot print line. Can I try to print out this one number of circles?
Yeah.
This one will work, right? Let me put a S over there because the number of circles. This one will work. This one is something we are familiar with, right? But this one will work, but what I'm going to teach you is that there is a difference between this one and this one. Okay, there is a certain difference between the two things. This one is not needed. Let me close it. Okay, let me close those. This one is needed. Okay, this one actually you compile and then you work. You come wrong. I'm sorry, this one's pi. I'll talk about this later. So let me actually run this one. Okay, so it says it's 0, so that one is correct. So let me put that cleaner over here. Clean out whenever we run, clean out the screen. Okay. So what this really means is that this variable is static, is global when the class circle is loaded to Java virtual machine. It is there already. But this radius is not there. This radius is not there. So whenever you run the Java virtual machine, you type Java and then circle, right? The program starts to run this static. So here it will run, and this variable when circle object is loaded to Java virtual machine, that variable already been there, but not this radius. Okay, the radius is called instance variable. Now let me talk about the difference between. So this one without static is instance variable. With static is a class variable, and we also call it static variable. So this one actually is called a class variable. So class variable is different from instance variable. Instance variable no static. Class variable has static. Okay, and what is the difference? Now let's look at the difference between class variable and instance variable. So class variable is alive when circle class is loaded. Okay, but radius is not. Radius is an instance variable. It only be alive when instance is created. But now we have no instance concept of instance, but we know that when the class loaded, I run the class method. This one is static, so this one is actually a class method. So class variable, class method is fine. So basically, these two are class. Whatever with static is class variable, and actually the instance variable, instance method, we never used that before. But today I'm going to teach you that. So this one, print out that's fine. But now I'm going to talk about instance variable. So instance is, since this class calls circle, so we can make a circle. So what we do is that we can type circle, okay, C1 equals new circle. So this one make a circle, okay, and here I put 5.0, okay, and 5.0 is what? I need to design something here. I type circle, and then like this, and right here I put like a double R, and I say radius equals R. So this one is called constructor. This circle function is called constructor. So the constructor function is the same as the class name. Okay, so as you can see right here, this guy's circle is the same name as this circle name, but there is no return type. Okay, there is no return type, absolutely no return type. But it is called a constructor function, but this function is special. There's no need for void, okay? No need for no need to put an integer. No, there's nothing like that. Okay, let's try. Okay, here actually let's try this. Let me compile. It's fine, but if I put a integer over there, okay, it creates trouble because this is no longer a constructor. It become a function, but is no longer a constructor. So no, that's not good. So I put it here, right? And right here, actually, I should say number of circle increased. Okay, and then here I say again copy to okay 2.0 and I create a circle 2. Okay, and then compile and I run. And the number become 2. Circle become 2. What does it mean? This means I try to build a circle because this class is circle. So I try to build a circle C1. So number of circle increased. Okay, so this number circle doesn't belong to C1. It belongs to the circle class. So that's why we call it class variable. It's used to count how many circle being created. So the next time I actually do circle C2, I increase again. So this circle 1, there is a circle 2. Both of them actually increase the number of circles. So here I know, oh, I build 2 circles. So that's called class variable. When some variable is shared by the instance circle, when it is shared by C1 and C2, now we call it class variable, and it belongs to circle class. Okay, it belongs to circle class. So let me clear it here. So the circle class variable, we can print like this. I can also do circle dot number of circles. So let's run it. And it's the same. It's still print out 2. And I can put some description. Okay, and I compile and run. So it says number of circle created is 2, right? And these are 2 different circles. So constructor is used to build a instance. Okay, so far you never learned this, but you have to remember this one. You can put a variable over here and then put some constructor over here and then class variable behind this one, or you can put it on top of the instant variable. But this radius belongs to the C1. Okay, it belongs to the C1. So here, let's do this. Let's do right here. Okay, let me actually print this. Let me copy this one. And then let me just put it here. Instead of printing this, let me do this. This one, let me close it. Okay. Right here. Here, I mean, C1s are equals plus C1 dot radius. Okay. System dot out dot print line. And then here I put C2s are equals C2 dot radius. Okay, so here I'm trying to print two circles on a radius. Okay, so C1 is 5.0 because I put 5.0 there. C2 is 2.0, so it actually print out 2.0. So what happens in this program? Actually, we demonstrate what? There is a circle 1 has a R equals 5. There is a circle 2 smaller than R is 2. Right, so we have this and this. Right? And the number of circles doesn't belong to any one of them. It belongs to the class circle. And number of circle equals 2 now. Right? So each time we increase it. But if I don't write it, if I don't write a increase in the constructor, it will stay as 0. So this one is a must. You must put a number of circle increase here in order to keep track of how many circle being created. But apparently this variable is shared by circle 1 and circle 2. So let me do this. Okay, let me do this. If I have this, I copy this one over, and then here I don't want to put radius. I say number of circles. Here I say number of circles. Okay, and here I say number. Okay, number. Okay, and I compile and I run. Both of them actually get 2. Okay, so that give you a rule. Okay, that give you a rule. This copy is shared by everybody. So you have the C1 as a 5 for radius. That's the C2, that's 2 for radius. But the number of the circles is shared by them. It can be accessed by the class name. It can be accessed by each individual circle. So static variable can be accessed by all instances. Okay, but static method cannot access instance variable. So this main function cannot access instance variable. This one is no. This one is yes. Okay. The reason why static method cannot access instance is that I have a class, but I'm not allowed to access each circle's own data. No, there's no way you can do that because you even don't know which circle you are talking about, right? So it's not allowed to access that.
Mm-hmm.
And here, and also static variable get started when the class is built. The function is already there, but instance variable is not there because if I don't call the constructor, C1, C2 is not even there. How can I access the radius? No, there's no way you can access the radius because before I created here, I created by the creator, the constructor over there. My radius actually basically not existing. So static method cannot access instance variable, but instance method like this circle, the constructor can access the static variables. Instance can access the variable static. So instance can access instance method, instance data, and also static data and static method, but static can only call static. Okay? So static belong to the class, instance belong to the instance. Is that okay so far?
I think so.
And this instance we never talked about it before, so you may see some variable put in here, but you never know what it is. Okay, so here you have the instance variable, class variable, and constructor, right? So here let's continue, right? So here I can have a method. In the past, we need to do this public static, okay, get area, right? And we can actually do here, this one is static method, and then say double and then here I put circle A, and then return A dot mass dot pi dot A dot radius times A dot radius. Okay, here should have a multiplication. Is this okay or not? I have a static measure, but I put a circle here and I try to print out this. It passed, actually it's okay.
Okay.
So this one is a class measure, right? But this class measure actually try to calculate the area for a circle. But it already specified the circle, so there is no problem. It already specified, so it's actually using the A dot radius. And the one here, it doesn't specify any radius. So this one already opened the circle for you. I know which circle it is, and I'm trying to calculate the area for you. So this one is a function helping all the circle to calculate its area. This is called utility function. Trying to calculate the area for a certain circle. That's called utility function. Okay, that one is called utility function. So that one, you need to specify the circle for you. Okay, if you don't have a specification for the circle, it's not good. So now let's do this. System that out that print line here. Let me say area of C1 equals plus here get area of C1, right? And let me copy the same thing, and here I say C2 equal get area of C2, right? And then I run, and then here I just print out. Oh, okay, here has the pi r square. This one 25 times 3.14. About it, right? About it. Okay, that's good. That means we had the right calculation. But also here actually is a get area, but you actually need to put the reference type, the circle in there, so it will go into the circle and look at each data to calculate it. Okay, that's one way to print out the area. This one is called static measure, static class utility measure. Okay, and now I give you another version. I say public double get area. Okay, and then this one without a circle. Okay, and then I return mass pi times radius times radius. Okay, this one doesn't give you any A or B. So this one actually talking about the circle of your interest, the your own circle. So that we pull this one up to here. Okay, so this method belongs to the circle of interest. Okay, so right here I have the pi. Let me put pi over here. Okay, so let me actually calculate. Okay, get a same result. Okay, now I have to get area measure, right? This one is a utility measure, so I need to put in the circle name over there. So now let me copy the whole line, but put it in front of the static one. And here I try to call this instance measure, so I just do C1 dot get area, and here C2 dot get area. So this get area method without static belong to the instance. We call it instance method. So instance method is that every circle has its own method so that you can get area for that instance. So when we call this one C1 get area, we already know that get area belong to the C1. So C1 can get area. So here I have a C2 get area, so C2 can get area. So let's do this. I'm sorry, not here. And then actually now let's run. Oh, it's also print out the area for me. So let me actually right here, let me actually cut it right here. Usually I can put a command line. So I put like this, and right here, these are class methods. So class method for what? For serving other people. And the instance method and instance data serving the circle itself. Even though both of them are calculating the area, but the one for the circle itself, the instance, I don't need to put a dot radius there because right here, this radius really means this circle and this radius here. But here, this one is a utility method. When you call, anybody can call it, and when you call it, actually need to figure out, oh, that's the circle I'm calculating. So that's helping me to calculate a area for a certain circle. Is that okay? So this one we call utility method, and this one is actually instance method.
Okay.
Okay. So now let's continue. Okay. Now let's continue. So here I have a get area. So here let me say here I can put public. Actually here let me see. Let me call it. Let's say boolean and equals. Okay. And here let me put a circle. Other. Okay. And return what? Return get area equals get area. Okay, what does this mean? Okay, now let's put it here. Okay, right here system.out.print9. Okay. So I'm asking the question is C1 equal to C2? Okay, and I define the function called equals. So if C1's area is the same as C2's area, then two are equal. So I type C1 that equals and put C2 here. Since I can also copy this one here. But I ask the question, C2 equals C1 or not? Here, actually, I have C2 and then compare to C1. Okay, compile. And then here I run. Okay. So, wait. I put it down. So two are not equal, right? Because the area are different. So here you see, I have my name. I have this C1. So when I do C1 get area, actually this get area belong to C1. And then C2 is the other circle. So other circle can call other. So this one is okay if I have the variable called circle. and I get the area for that other circle, that's fine. So same thing in this get area, it actually already specifies some circle, and that circle to get some radius, that's fine. Okay, same thing over here, the second one, let me use red. It is C2, so C2 has its own get area compared to other. Now the other is C1. So this one actually is a instant measure for C1 or C2, and then if it is C1, it compared to other actually is C2. When you use the C1 that equals. So when you use the C2 that equals, that circle, that get area belongs to C2. And then you compare to others, and then at that time, other is C1. Okay? So that's this one, the equals. Okay, now let's do this. Now let's here, let's create circle C3, right? Equals new circle uh, 5.0, right? So this one, make sure it will be equal to C1's area, right? So let me see here. Let me copy again. Let me copy the two thing. Okay, copy the two. And then right here, I put C3, C3 to that. C1 and C2 both compare to C3. Right? And then let's go. Okay, so C1 equals C3, but C2 not equals C3, right? So apparently that the get area method that belong to this method. So all of these right here, all of the thing that we did except this one, all of these right here up to here, up to here, anything without stable static, it belong to a certain circle. So let's look at put in lowercase, belong to certain circle. Anything actually has the static, it belong to the class circle. Is that okay?
Mm-hmm.
So now let's do this. Okay, now let's do this. Okay. And I really don't like this to be confusing. It's really confusing because static putting in the same class and then it still work. I don't like it. Okay. So let me create something called test circle. I create something called test circle. I delete this garbage and delete this garbage as well. Right? And right here, oh, I really don't like this to be put into the same class, so I cut it. And then I put it here. Right? And then, oh, okay, there's a line saying, this line saying actually test circle use. So this line actually, when you see this actually is a use relationship, or sometimes people call has a relationship. So test circle use circle, or test circle has a circle. Okay, whatever. That's a use relationship. So test circle use because it actually has the something that over there. So let me remove this. Okay. And the circle is in other class in over here. It's not in test circle. But this is fine because it's a utility. We write this to help test circle. Right? So compile, no problem. That's wrong. Oh, no problem. It's actually like nothing has happened. It's just like you are in the same class. But let's go back to circle. This one actually completely no. This one completely no method at all. But it compile, it passed. So the main function is not a must in the class. The class at least need to have some data or some method there. But can I move this static variable also to that test circle class?
Mm, No.
No, because it belongs to circle class. It doesn't belong to test circle because test circle is not cannot keep track of the number of circle for other class, right? So this one actually fine to be here, okay? And these two actually, as you can see, you can move here to the circle or go back. It doesn't matter because this one actually look like this. It actually become something like this. You actually have a circle in there, circle class, and you use that circle class to create C1, C2, and C3, right? And then that test circle class is like something called, we call it a test bench, right? That's the test circle. So you try to test it, okay, give the signal to there and test the data, whether the program work or not work. Now we call it test bench. So let's look at the test bench. What is test bench? In the old day when there's a lot of electronics, there's a bench table. There's some test table. Okay, so people use that to test electronic devices. Okay, so that's testing. You keep some signal there and then try to test whether the circuit is working or not working. Now we call it test bench. So similarly, we have a class and I want to try whether the circle really work or not working, right? So actually, I have to test whether they are the same or not the same, or some data. That actually this one is actually called test bench. So you can have a class that used as a data class. So this circle is a data class. This circle is a data class. It contains only data. This test circle is a tester class.
Okay.
So sometimes this is called tester class, sometimes it's called driver class. It drives somebody else. And this one is purely for data. Okay, that one is purely for data. And this get area you can put into the test circle or you can put into the circle. It doesn't matter because it just use the class over there, the circle, to help people. But to be more useful, usually this one should belong to the circle class. Usually it should belong to the circle class. Okay. Usually it will belong to circle class because at that time, when people want to use this utility function, they'll think about, oh, it's belong to circle, and then I can call it. But once I cut it from there, I actually have trouble to have this class method to work. At that time, then I need to put circle. And this one, let me see, also put circle, because I need to get the class method from the circle class. Then it is fine. Then it is fine. So when you access a class method, if it is in the same class as your data class, then you don't need to put the circle. But if it is in different class, then you need to put a class so that I know, oh, what is the get area, or I need to get it from my circle class, right? Otherwise, where is the get class? It can be cut already. I cannot find it, so I need to say, oh, it belongs to that circle class. So I actually can get the circle class. I actually will go to my circle class. I'll go to my circle. So, oh, there is a get area I can use. That's the get area I get. So do you know some of the other class methods so far? You have already known several. What?
Static one?
No, whatever class method you know so far. Not static. Static is used. Okay, static is used to describe a class method, of course. But you have already used many of the class method, but you just don't know they are class method. Like mass.pow,
Oh.
right? That like integer that parse int, right?
Mhm.
Like character that is digit, right? Or is letter. Remember this,
Yeah.
right? Anything with capital letter, these are all class methods, and it belong to math class, integer class, or character class. And they provide a function for other people. So this, I call it utility functions. To try to serve other people. So the same thing, that get area I told you, that get area is what? It's a utility function that helping other people. But if I want to put into one class, it can be in the test circle class, or it can be put into the circle class. Either way is fine. But if I have my own preference, I will put into the circle class. It's just like that whole circle class provide all the services just like character or integer. Integer class is actually create all the service for other people. Okay, so a class provides service for other people. It also provide the building of certain circles. You know what I'm saying? So you have a you maybe have a Benz car, right? Mercedes Benz car. You
Mhm.
make a car, right? It makes a certain car, but whenever 3 months, 4 months, you go back for service. So they have a new car, right? This one's new car, and then they have a scheduled maintenance. That's utility. You know what I'm saying? Now help all the cars. Similar.
Okay.
So circle should contain these different things, right? And actually, you can have a say some company like Speedy or Speedy D, right? There's some or some maintenance company or Loop Oil. They will help you to do maintenance. That's third party like this test circle. That's fine. But usually, if you are Mercedes Benz, you can build your car. You provide a service as well. Everything related to circle, I would like to put it together into a circle class. Okay, that's how a class is. And now class can be used to build instance. And when we talk about instance, only the one without static belong to the instance. I build a circle. It has a radius. It can get its area. You can compare whether the two circles are equal or not, and that is in one class, in one instance, one circle instance. Okay.
Mhm.
And now, in the first place, we talk about if the static variable is put into here, right? It is put into here. Now, the question is, I told you there is A, B, C area, three different area. I talked about this already. That's actually when you say static, you put in here. But how about my instance variable? How about my instance, my C1? Where is my C1? Where is my C2?
Um.
Okay,
Uh.
and then where is my int variable? Okay, so now let's do this. Okay, so now let's look at where they are. Okay, so now in my class, if I put a static integer number of circle, it will be put into where? It will be put into the static area, right? But if I have double radius and this different thing, say for example, if I have in my test circle right here, I have circle one, circle two. this few variable, I can have over integer x equals 3, right? These are called local variables. These are called local variables. Okay, these are called local variables. So these local variables are belong to where? It belong to the stack. It belong to this Java stack. It belong to this Java stack. So when my actually my main function, right? I have my main function, and I have C1, C2, C3, right? So C1 actually is a variable that has a reference, and the reference pointing to an object, pointing to an object in here. So there's a C1 data over here. So so what will happen is you will C1 this variable reference that actually is in stack. So when main function is called, my C1 is alive. But if my main function finish, my C1 is dead. But at that time, I actually create a new circle, but that circle go to my heap area. And in my heap area, I create a C1 object, and it has a radius, and it has method called get area, and get area will point into the static method area to run the program. But that the object actually belong to heap, and heap will assign some ages and put the ages into C1. So in C1, it actually holding 5, 3, 4F or something. That is the ages, and that one actually pointing to the C1, and C1 actually put into the heap. Okay, so this we call it a reference variable.
Okay.
So let me show you some Java's diagrams. I use this again, and I say Java instance in heap. Okay, something like this. Okay, they will show you a lot of diagrams. Let me pick a good one for you. Okay, this one is a good one. So as I say, I employee 1, employee 2, employee 3, right? And those variables are actually put into stack because they belong to certain function. Okay, it may belong to certain function, but it actually hold the ages for argument 1, that's a string. So the string actually, the body of the string put into heap. Body of employee also in heap. Body of employee 2 also in heap. So whatever object is a body of an instance. Object is the body of a instance. So when I have C1, my body actually is 5.0, get area, those different things, that's the body. And my C1 is only a ages. Okay? My C1 only a ages. So let me clear this. So those body are put into the heap. Now, let's do this. Let's go back to my program, right? And then let me actually do my C circle. C4 equals C1, right? My circle C5 equals C2, right? And let me copy down these things like I just need this. Okay, so I did not create any new circle. Instead, I actually just copy the reference, the ages of C1 and C2 to C4 and C5, right? And then I try to get access to these two variables. And what happened is, let me see. What happened is, let me actually run this test circle. Oh, I'm sorry, I may have a typo. This one should be C5. Let me do it again. Oh, 5.0, so my C4 is 5.0, C4 is 5.0, C5 is 2.0. Now, let me do this. I just do C4 dot radius equals 7, C5 dot radius equals 1. And let's see how it happens. And I copy this down here, right? And right here, I change it to C1 and C2, right? And here I have a C1 and C2, right? And let me test it again. And then the result is, oh, my C1, C2 got changed, right? So what happened? It actually is, I have a C1 pointer point to the object, right? I have C2 pointer point to the another object, right? And then now my C1 copy to C4, so my C4 pointing to here, my C5 pointing to here, right? Originally they are 5.0, 2.0 here. Now my C4, I use the C4 to change this to 7.0. And I'm using my C5 to change it to 1.0. So C1, C2 got affected. Okay, so the object in the heap is real data. And this reference, so when you say circle something, it's just a reference. It's just some ages. It's just holding some ages. So you can change, okay? You can change the ages. And the body of the person never change. If somebody make a surgery for you, you are done. You actually permanently hurt you, okay? But your ages can never always change, but nobody knows who you are. You can change your name actually, right? So if so, let's go back to this one here. And since I assign C1 to where it is, so I can also do this C1 equals null. This is called parking. Parking means my C1 no longer point to anything else. So here, if I say system.out.print line, and I try to say C1.radius, I'm sorry, you have already parked your own car. So C1 cannot pass because you did this. You have a C1, you hold the ages to a certain object there, right? Originally, you have this, you own the house, right? But now you sell it, you just assign your own self. Null is 0. You have nothing pointed to anywhere. So when you try to say, oh, where is my radius? No, you have no radius. You already assign yourself to parking status. Is that okay?
Yeah.
But I park, C1 park is okay, but C4 still alive. But when C4 is also parking, say C4 parking now, then this one, no one pointing to it. This is called garbage. When the data is completely lost, nobody actually reference to it. It's a garbage.
Okay.
And then Java has garbage collection.
Okay.
Garbage collection means that, okay, there's an orphan, this one don't like it, the other one also don't like it, and then, okay, somebody just collect it, make it reusable. So Java had a mechanism for doing garbage collection. Okay, Java has the mechanism to do garbage collection. Or you don't need to know about the detail about garbage collection. Just need to know whatever data no one pointed to it will be collected by garbage collection. Okay, and if you park a certain variable improperly, that will actually cause garbage. Okay. If you don't know whether there are still somebody holding it or not, you will lose it. But it's fine. You lose it, it's fine. Somebody will reclaim it, and then that memory will be reused. Okay, so don't worry about that. If you really don't need it, you can just give it up. Okay. Now let's do this. Let's come to our textbook. Okay. So we have immutable object. I compare the primitive versus object, right? This one I actually talked about it already. So you can go to this website to start it. I covered this already. String not immutable. Okay, string not immutable. What immutable means is that it cannot be changed. So string is also a class, a object. So you can use a string name equals Aaron string. But when you say the name to uppercase, you can't change the name's content. It actually will create a new string. So basically what this means, immutable means what? You have a string called name, right? So name actually is equals to this Alan Turing, whatever, right? And then later if you say name equals this name that to uppercase, say, it will generate a new string and then assign to it. So basically, originally you have an object, and it's say is in lowercase at, and you convert it to a uppercase at. That's a different object. Originally you have a name pointing to here, but if you just do name that to lower uppercase and assign the same result to name, so name will be changed to here. But the data itself is not modified, so we call it immutable. When data can never be changed, we call it immutable. And actually, sometimes you just change the pointer. So when you do assignment, say a reference is C1, but assigned to C4, that we call it redirection. The assignment actually is the redirection. So maybe original C1 point to some object, and later we copy C4's object and then C1 pointing to here. It's called redirection. This one got cut, and C1 now pointing to here. That's called redirection. Okay, but if you do some object, if you do C1 dot radius equals 7, that is changing the content, the body of the C1. The radius got changed to 7, so that is changed. But for someone like a string, you can never change its object, its body. That's called immutable. You can generate a new string, but actually that's a new one. It will actually go to somebody else. So now the next one is rebel class. Okay, so rebel class is like integer is not a class because it's a primitive data, but there is a rebel class called integer, integer. That's called integer. So we have some function like I told you. These are some utility like parse, or there is an integer that mean value or integer that max value. Those are rebel class data. So now let's look at a new program. Okay, let's look at the new program. So here, let me say this is wrapper. That is a rebel class. So here, I originally say integer 3, right? I equals 3, right? But this one I can only do like integer b equals a times a, something like this, right? That's the only function I can do. If you are primitive data, you can only do arithmetic. But I can also do this integer AA equals new integers A. That's a wrapper class. So the data is A's data, that's 3. But actually I wrap with the integer class. So it become an object. It become a reference data type called AA. Okay, and now I can actually have some function with the AA. I can actually do string A string equal AA.toString. Then actually this AA converted to string. But originally my A data, I cannot do A to string. No, I cannot do that. There's no way I can do the A to string because it's not an object. But now I get this one called, so I can actually do system.out print line. I put A string in there. So that actually is a wrapper class. I wrap up the data, and then I can actually print it. Okay, I can somehow print it. That's fine. That's fine. That's perfectly fine. But but if every time I need to do this wrapping, unwrapping, it's actually very time consuming. The good news is Java provides you the auto wrapping and auto unwrapping mechanism. So actually I can do this. I can do integer. Let's see. I can do integer x equals 3. That's fine. Okay. I can do integer y equals x. That's also fine. This is called auto boxing. The other part is called auto unboxing. Okay, so what's auto boxing? Auto boxing means as long as I assign a integer value to an int. Originally, I need to do integer x equals new, and then integer 3, right? In order to box this, to wrap up this 3 in the integer box, right? But there's no need to do that because I just do this. It is actually a auto boxing. Is that okay?
Mm-hmm.
And then this one actually is auto unboxing. If my x already been boxed, and I just assign to an integer, that's auto unboxing. Okay, so what this will do actually is, let me run it. Okay, let me run it. Compile and run. Okay, so it's auto boxing. It will provide the result, no problem. But what this good for is not here. It's actually here. What this actually would be helping people is that I have an integer list equals this. Okay, original if it is an integer, I need to do this. This is actually tedious, right? Right, that's quite tedious.
Mm-hmm.
And then I can do this one. I can do this one. Okay, because it's the object, so here I actually can compile and then I can run. Okay, so as you can see, I can print out the whole array for it. But this is really stupid, so I can actually just put this with auto parsing. I can actually just put this, and that makes things easier. Let's put 1 there. Okay, let's put 1. I don't like 5. Let's put 1. I don't like 9. I put 1 here. Okay, so you usually print out this. So that's good for auto parsing, right? But there is something more. I can just do this sorted. So there is a question like, okay, since the parsing or the wrapping is so difficult, then why are you ever spend time to do these stupid things, right? That's because once you is a in integer type, you can do sorting. Let me see. You can do sorting list. Let me see what's wrong with that. Void type not allowed here. Let me see. Array list that sort. Let me see. Okay. Let me see here. That is. No, it actually is. Oh, I see. I know. Okay. So, and then here, 9. For this. Wait. Void type not allowed here. How come it's the void type? Let me put new here is new integer is new integer is void type not allowed here. Let me check. Let me check the function for array sort. Array sort. Oh, I'm sorry. I'm sorry. I'm really sorry. So this one actually it doesn't provide a return type. So I need to put it out here. So it actually need to return. It actually doesn't return anything. So that's nothing to do with these numbers. So it actually is fine. 571 is fine. 571 is fine. Okay, and then I'm sorry, 571 is fine. And then this list after sorting, the data got changed, but I still need to print out the list. So the array that sort doesn't return anything. It's just sorting the list for us. So this is just a example to tell you like, okay, you wrapping the data up, it will help you to do sorting. It will help you to actually print out the list in a more organized way. Okay, so wrapping class is some sort of providing more function to your variables. Okay, it will provide more function to your variables. So that's the advantage of wrapping class. And you can wrap up integer, you can wrap up double, wrap up long, wrap up character, whatever there. And you also have the maximum value, minimum value, that you can use. That actually you can actually have the maximum integer. You can say system.out.println, and then I say my integer dot min dot max value. Okay, I have a question. What is this variable? Is it an instant variable, or is this one a class variable? Max value. Max value.
Oh. A class.
Yeah, it's a class variable because it's accessed by a class.
Yeah.
Right?
Yeah.
So that is a constant for people to see. It's in integer. This one is the maximum value that can be represented by any integer type. So integer type, the greatest number in integer type is this number. The minimum one is actually called integer dot min, capital MIN, underline value, capital. Okay, and we use this for sorting. When we go to AP, we will use this quite often. Okay, but now just know there are some variable like that, and then this is fine. Okay, and then sorting part is talk about it. Command line argument. Command line argument is whenever you have a argument, I can actually print out the arguments. Okay, so let's do another program. That's one. This one's easy. Here is, let me create a new program. This one is no longer suitable. So here, let me print out this one. Command line example. Command line example. Actually, this one. Let me actually clean this whole thing up. Clean this whole thing up. And here, public static volume string args this, and here I can system.out.println. Okay, I clean up the page first, and then I have system.out.println, and then I say arrays that speech, and then I put args over there. Here I say import java.util.arrays, and in here I say system.out.println here, say number of arguments equals, and right here plus args.length. Okay, it's a simple program. Compile, but I don't want to run it here. Let me go to the command line. So I have here chapter 9 right here, right? I see a circle, pi, my test circle, and now the wrapper. So let me open with some other editor. Okay, it's there, right? And now what I'm doing is command line. I need a command line. I open with the other editor. Okay, this is fine. Right here, I hit Window R, open up my command line. So I hit my Window R. Window is this key, right? Window is this key on your lower button part, and an R key. You hit a Window R, and then click OK. It come up with this. I say CD space, and go to this Explorer line, left click, right click, copy, go back to this window. Here I hit the right mouse click, hit return, dir. Here I have the note, everything here. Now I do command line compilation. I do java c command line .java. You compile the program, then I run java command line. I say I am super happy person. Go. So I am super happy person, right? So it's 1, 2, 3, 4, 5. The number argument is 5, okay? And it is put into a array format and print out. Is that okay?
Yeah.
So what this is actually is an array of strings. An array of string that it actually usually is, if you run in the command line, the argument here actually been taken to the program, and then it's a string array of strings, and then if I print out the array's length, it will be 5. Okay, it will be the number of the element arguments over there. Okay, now this one's okay. I go to the command line, that's fine. The command line, you just continue to read, okay? The next one is big arithmetic. What is really is big arithmetic? Big arithmetic is also a wrapper class. It's also an object type, and it's also a immutable class. It also is an immutable class. Okay, so the data cannot be changed, but it can be used for calculation. But why we need a big integer and the other one called big decimal? Big integer actually is for integer. Your integer has integer and then long or something, right? But big and then big double is big decimal is for double. double or your floor type for real number. This is for real number. This one are for integers, right? But no matter you are using integer or long, there are digit limits that you cannot break, right? There are digit limits that you cannot break. So we need to have the big integer or big decimal. Now here is an example of called pi example. So actually right here, I am trying to calculate pi to a very fine digit, okay? So I'm using the equation. I'm using the equation right here, this guy, not here, this one. No, not this one. Let me try to find another one. Wait. Oh, here. 5 ways to calculate pi. Okay, this one. How to calculate pi. Not only one digit, not 10 digit, not 100 digit. It's more than the number of digits you usually see. Okay, so this one, give it to you. So here you have the pi. So here I use this equation, okay. So pi number, actually you can use this equation. This one's an easy equation. So pi equals 4 times a big thing, okay. This big thing is like 1 minus 1 over 3 plus 1 over 5 minus 1 over 7. So that's what? Pi equals 1, and then they add 1 over 1, odd number, another number, and alternating the size, sign. Is that okay? This one is called a pi, and this pi is called Leibniz series. Gregory Leibniz series. And Gregory Leibniz series can be used to calculate pi. Because I want to calculate very long digit. Okay. So I found this equation. Okay, fine. Then the next one is I want to do so many steps. And in each step, I have the Leibniz term. Okay, so Leibniz term is actually minus this 1 over 3, right? 1 minus all this plus 1 over 5. So this one is called Leibniz term. So the first term is 1 over 1, right? 1 over 1 is if for I equals 1, it actually is 1 over 2i minus 1, right? Because it's odd number, right? So here I have the 2i subtract by 1, that's 2i minus 1. And then 1 divided by 8, that gives you the term. And then I need to multiply by sign. So actually the sign is minus 1, I minus 1. So it actually is minus 1, I minus 1 times 1 over 2I minus 1. Every time I sum with this one, it's the algorithm like taking sum. So originally I take my my own pi is 0. So this look you like a sum. And every time my pi add my term x, and then my 10x equals minus 1 to the power I minus 1 times 1 over 2I minus 1. That's my x term. And every time that is one of these term, or this term, or 1 minus 1 over 7, one of these term, is called external. So every time I do it and I multiply by 4 in the last stage, and by doing this, I can calculate my pi. Okay, so actually I have my rounding of 100 digits. That's my the number of digits I want to do, but I do so many steps. Okay, and then see how good my program is. So let me actually clear here. Okay, then let me run it. That's the way I try to use equation to calculate pi. Okay, and it keep going. Keep going. See when you were done. If you're done. Oh, it come out. Okay, it come out. Then I need to move my. It's only 100 digits, so it's 3.1415927. So this digit already rough, right? Right?
Mm-hmm.
Are you okay?
Mm-hmm.
But this one actually will give you some estimation. But this one just using the rough Leibniz series. Okay, so there are tons of different methods to calculate pi. My way may not be the best way. There are several different ways of calculate pi. Right? Calculate the number of pi, but you can investigate into this problem. But right here, I'm just showing you using the big decimal you can use to calculate pi. And then how good it is, I don't guarantee it, but it is. I want it to be 100 digit. I can calculate to 100 digit, but apparently in the 6 or 7 digit, it already went sour. Okay, it's not really very close to the number it should be. So something wrong with my algorithm because somewhere it's not so accurate. Maybe it is rounding method, maybe something else. But I don't have time to continue to study. But for some people who want to continue to study, this is the starting point that you can look at. Okay.
Mm-hmm.
So that one is why we need a big decimal, big integer. Okay. But for your knowledge, big integer and big decimal are not AP level. It's not going to be tested. So program development, you have the program developer, and then you actually build up your class like the circle I told you, and then you actually try to use the circle and then build your method around your data. Okay, so I have a get area different one, and then you can have more generalization, try to print table. This one actually we done that before for multiplication table. So you can study this. I don't think this hard. And then we finish chapter 9 over here. And what exercise you want to do? Let me see some more challenging one for you now because you just come back from vacation. So okay, so do even numbers. Is that okay?
Mm-hmm.
So do those even numbers. That's it for today. Let me end the meeting because your mom still want to talk to me.
Okay.
Okay, so that's ended right here. So, okay, I'll talk to your mom anyway. So, good night, man.
Good night.
Good night.